Okay, so we're going to start by multiplying this by the conjugate. So cos x plus 1 over cos x plus 1, just swapping the sign so we can get a trig identity. So the next line is going to be the limit as x goes to 0 of cos squared x minus 1 all over x times cos of x plus 1. Now, this might not be the exact identity that we would have wanted, but we can do something here to make it that. So what I'm going to do is I'm going to factor out a negative from this. So when you factor out a negative, you end up with 1. The 1's going to be positive. And I can write this instead of plus, it's going to be minus cos squared x. And now we see this identity pop up to what it's actually going to be. I'll write it out here just so we can see it. So it's just sine squared x plus cos squared x equals 1. And then we get that sine squared x is equal to 1 minus cos squared x. And then we see that right here. So we're just going to rewrite the same thing in the bottom. And now what we can do is rewrite that in. So we have negative sine squared of x over x cos of x plus 1. Now using a limit property, we could take out the negative and put it in the front because it's not affecting the limit as x goes to 0. So we have negative limit x approaches 0, and we can write sine x twice. So sine x over x times sine x over cos x plus 1. And you can evaluate these separately. So evaluating this, you're going to get 0 as such. So we get negative times, or I'll just write negative 1 times 1 like we just proved in the last video. And then this one is going to be 0 over 2. So this entire limit just becomes 0 because of this 0 multiplying everything through right here. So that's the proof of this limit. We have to use the last limit proven geometrically to prove this, just because we don't want to get into L'Hopital's rule and stuff that we haven't seen theorems and proofs of yet. So this is the way you prove that cos x minus 1 over x, the limit as it tends to 0 is 1.